Today, if you recall yesterday, we found the unit rates, and if we compared unit rates, we would find that that would tell us if our ratios were proportional and or equal, same thing. And so just want to review with you, one of the definitions was that a unit rate, if I call it K, and that's our unit rate, then Y is equal to K times X, where Y is the denominator in our ratio and X is our, Y is the numerator in our proportion and X is our denominator, and that's the way all of our tables were yesterday. And we saw this definition, and so today we're going to use this a lot. Okay, so, and we also want to remember that you're always going to take Y divided by X to get K. And that would make sense here, because if I divide both sides by X here, K will be alone and I'll have Y over X. But this is the one we use more than anything. So just make sure you're following along with that. And tomorrow, if you don't get that, you can ask questions, but I think after we're done, you will. Okay, so we got a new self-serve frozen yogurt store opening this summer that sells yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabella's family weighed their dish, and this is what they found. Okay, so if it weighed 12.5 ounces, it cost $5. 10 ounces, $4, and so on. So whenever we look at this and we're talking about our unit rates, it's going to be cost per ounce is how we would usually do that, just like we did in that grocery store example with the pencils the other day. We always usually say a unit rate, if we're talking about ounces of peanut butter, it's going to be how much it cost per ounce, or how much a pack of pencils cost per pencil, or how much a thing of toilet paper weighs per sheet of toilet paper. So in this situation, the unit rate's going to be cost, in this case, dollars, and it's going to be per ounce. So that means we're going to be dividing dollars, or the cost, by the number of ounces, which is the weight. And so we're going to make our cost Y and our weight X. So we'll say that's Y and our weight is X. All right, so it says Isabel's brother. Oh, first of all, we want to say, are these proportional? Well, if they are, which they should be because they're charging the same amount per ounce to everybody, then when Isabella's brother gets up there with his 15-ounce dish weighed, he should pay a proportional amount to them. So let's see. First of all, let's find out the constant of proportionality, and that should be how much they're paying per ounce. So if we take $5, the Y, and divide it by the number of ounces, 5 divided by 12.5 is going to equal 0.40, and so that's 40 cents. If you take 4 divided by 10, well, that's 4/10, that's easy. And if you take 2 divided by 5, 2/5 would, if we get it into tenths, would also be 4/10. And if we did 3.20 divided by 8, 32 divided by 8 is 4, so 3.20 divided by 8 is going to be 4/10. And in every situation, that's really 40 cents. So if I multiply 12.5 times 40 cents, 12.5 ounces, that's going to cost $5. So if I take 10 times 40 cents, that's going to be $4. If I take 5 times 40 cents, 5 ounces by 40 cents per ounce, that's going to be $2. And if I take 8 times 40 cents, that's going to be $3.20. So how would I calculate his? Well, I'm using this right up here. I would say that his cost, and we're calling cost the Y would equal the cost per ounce, which is our K, which is going to be 40 cents, times 15 ounces. And this is 40 cents per ounce. So there you can see the ounces canceled, just like dimensional analysis. And so 15 times 40 cents, 15 ounces times 40 cents would be $6. So it should cost $6. All right, so if we look at the next example, so this is a cheat sheet for cooking. And again, it's conversion. So you could say how many cups are in an ounce or how many ounces are in a cup. But it says is the number of ounces proportional to the number of cups. How do you know? Okay, so if it's ounces proportional to the number of cups, then we're doing ounces per cup. I'm just using a slash, but you could also say per, or you could use the colon. All right, so ounces per cup means it goes ounces in the denominator and cups in, ounces in the numerator and cups in the denominator. So that means our cups is going to be X and our ounces are going to be Y. And to find our constant of proportionality, we want to divide ounces by cups. Well, right here, if I do 8 divided by 1, my constant of proportionality is 8. So 8 times 1 is 8. Here, if I do 4 divided by 1/2, that's the same thing as 4 times the reciprocal, or 2 over 1. Well, that's also equal to 8. If I do 12 divided by 1.5 would be 3/2. That's going to be 12 times 2/3. My 3 cancels with the 12, factors out, and I get 4 times 2, which is also 8. And then, of course, 16 divided by 2, that's also going to be 8. So they are proportional. And how do we know? Because we found the constant of proportionality, K, was equal to 8 for every ratio. All right, what equation could you make if you converted cups to ounces? Well, let's do ounces to cups since that's what we're doing up here. So ounces to cups, we say Y is equal to 8 times X. So I'm using again the Y equals K times X. So Y is equal to 8X. Now, if I wanted to convert cups to ounces, then I would have, this is my cups here. The X, remember, is cups, and the Y is ounces. So that's going to be, well, if I want to solve for X, I can divide both sides by 8. When I do that, that means it's going to be X alone equals Y divided by 8. Or if I want to know the constant that is in front of the Y, I can break that down into X is equal to, when I divide anything by 8, that's like multiplying it by 1/8. So that would be 1/8 Y. And so my constant of proportionality, if I do it the other way, would be 1/8. So if I come back and say, I want to know how many ounces are in a cup, then if I have 1 cup, how many cups are in an ounce, then if I take 8 and multiply it by 1/8, that'll tell me that there is 1 cup in 8 ounces, because I'm solving for cups here. So how many cups are in that many ounces? Just take it times 1/8. All right, so the next example, during Jose's physical education class, we've got activity stations, and next to each station it tells how many calories on average would be burned completing the activity. So if we're looking at calories burned per minute, that means it's going to be minutes is going to be in the denominator and calories is going to be in the numerator. So this is my Y and time is my X, calories is my Y. So, and I forgot to fill out the values down here. This should be 1, 0, 11, 22, 33, 44. All right, so if I take my Y and divide it by my X, Y divided by 1, of course, my constant of proportionality there is going to be 11. If I take 22 divided by 2, it's going to be 11. 33 divided by 3, 11. 44 divided by 4 is going to be 11. So are they proportional? Yes. And I know because my constant of proportionality, K, is going to be 11 for each ratio. EACH ratio. Okay. So if Jose jumped for 6 minutes, how many calories would he expect to burn? Well, I could go up here and do 5 and 6 and then go halfway between and see how many calories that is. Or I could also use the equation again, y equals kx. So in this situation, it would be y is equal to 11 times x. And if my time is 6.5 minutes, I can say y, my calories burned, is going to be 11 times 6.5. And 11 times 6.5 is going to be 71.5 if you multiply those. Whoops. So it's 71.5 calories burned if I do 6.5 minutes of exercise. So that many calories burned. All right, so if we look at the next sheet on the back, now we're looking at an example. It says, Alex spent the summer helping out his family's business. He was hoping to earn enough money to buy a $220 gaming system by the end of the summer. Halfway through the summer, after he worked for 4 weeks, he had earned $112, so right there in that chart. And here we know that for every week he works, he got $28. So he's getting $28 per week. So it's going to be dollars per week. So this is going to be my Y, and weeks are going to be the X. All right, so it says, if I continue to work and earn at this rate, I will have enough money to buy the gaming system by the end of the summer, will I? Okay, so we're going to see if he does. So first of all, are these two ratios proportional? Well, 28 divided by 1. So my constant proportionality is 28 because I make $28 per 1 week. So if that's the case, in 4 weeks, when I multiply that by $28 per week, that should be 112. Or if I take 112 and divide it by 4, I should get 28, and that's true. So in that case, if we wanted to fill out the rest of the chart, and we don't really have to, we could just go down here and multiply 8 times 28. But if we did fill out the rest of the chart, 2 times 28 would be $56 after 2 weeks. After 3 weeks, times 28 would be $84. After 5 weeks, it's going to be $140. After 6 weeks, 6 times 28 would be $168. 7th week, or 7 times 28 would be $196. And after the 8th week, then it would be $224 that he earned after 8 weeks. So does he have enough? Yes, he does. And then are Alex's total earnings proportional to the number of weeks he worked? Yes. How do you know? Because we came up here and we compared, found the constant proportionality for each of those. And 112 divided by 4 is 28. 28 divided by 1 is 28. All right, so in summary, I think you could read that summary yourself because I'm running out of time. But this basically just summarizes what you need to know to do your assignment tomorrow, and gives you your equation, all that. So you can read that on your own, and your homework will be come back and show me, or me checking your work will be to come back and show me that you took these notes. Have a great evening.